Hello guys, hope you're doing well. This is class for Monday, uh, July 11th, and I'm going to solve some question for conservation of mass and momentum, which helps you how to solve the question in homework number 5. Also, I guess we need to extend the deadline till Thursday night, which gives you more time to focus on this homework. One of the most important chapter in fluid mechanics. So let's go for the solving three questions here, and I will show you how you can analyze control volume and solve questions. So first of all, the first question is a tank that you see here. You have a tank and the flow comes in from top and goes out from two output that you see in these two parts. The tank is when the tank is empty, it has a weight which is 450 Newton, and it's placed on a scale. And water also has a weight, and it asks you to find the horizontal force that needs to keep it constant and stationary. Okay, so first, what we need in any question, we need to first list assumptions, right? So first, list or assumptions. Okay, if we list assumptions, what we have here, first, it mentioned that the flow is a steady state. So one is steady state. Second is okay, here tank does not move horizontally, so it's stationary. So tank does not move horizontally. And three, the raw water is constant. We can assume that, right? Raw water is constant, means incompressible flow. Okay, so these are the assumptions. Second part is to define your control volume, right? You have to define your control volume. So for the control volume, you need to first try to, when you have an input and output, make sure that you are normal to that velocity. So here we have normal to this side, and also comes down there to be normal here, and also we need to put our boundaries here, right? Because we want to take the reaction force here. Okay, so this is my control volume, and we can put some names here. So here also, that's our normal directions, always outward. So these are our n, and you see that n and velocity here are parallel. Then let's put names here also. Number 1, this is going to be your 2 or 3, and this is going to be 2. Okay, so you define your control volume. Now the third part is conservation of mass, right? So you need to apply conservation of mass. So if you remember the equation that we talked about that in the previous class, the conservation of mass or continuity equation is rho over T, rho d volume, plus on control surface rho v dot n times dA, right? It has to be the total derivative of mass in system, which is 0. Okay, and also since it mentioned that it's a steady state, this is going to be used also 0, right? So that's going to be the only term. But what would be, since you define your control volume always normal to the surface, then V dot n always going to be equal to V, because the amount, the magnitude of n is always 1, right? So and V dot n is always amount of V, magnitude of V, magnitude of n, and cosine of the angle between these two, right? Since this is 1 and also angle is always 90 degree, right? The always sometimes 0 and sometimes minus pi, so sometimes pi, so sometimes going to be 1 or negative 1, then the amount is always V with sign, right? So we will find it when we are going to analyze part per part. But what will happen here? It means that you will have a sign behind that because of V dot n, but what else? Rho a V, which is your m dot, right? Then you can write it down here that the control surface integral term is actually summation of m dots, right? Okay, and summation of m dot should be 0 in the control volume. What does it mean? The amount of the flow that comes in should be equal to the mass flow rate that goes out, right? So if you say your 1 and the flow comes in, then m dot has to be like this. M dot of 1, it has to be equal to m dot 2 plus m dot 3, right? What else? You know that m dot is rho av, right? Okay, we have to write it down because we already mentioned what is the signs, because we put the signs of output in one side. But if you're going to find V dot n, then you can write it here. V dot n here is positive, right? It has a positive sign. Just also here it has positive sign. But here V dot n, the angle between these two is pi. Cosine of pi is going to be negative 1, right? So that's why m dot 1 is one side and m dot 2 plus 3 are on the other side. Okay? So if you replace this, what we will have? We have rho v1, right? And pi d1 squared over 4, which is area of the part 1, right? It's a circular shape. It has to be equal to rho v2 pi d2 squared over 4 plus rho v3 pi d3 to the power of 2 over 4, right? These are your areas, okay? But what we know about that? We know that rho are constant, right? These are constant. Okay? What else? We can cancel out pi over 4 from each side, right? So we can multiply each side in 4 over pi. Correct? Then if you do that, what will you have in equation? In this equation, it could be summarized as v1 d1 squared, right? Here cancel out pi over 4 and also rho from each side. Then it should be equal to v2 d2 squared plus v3 d3 squared. Okay, this is our equation 1. Let's keep it here. What we need now, we need to apply continuity of momentum, right? I'm sorry, conservation of momentum. So conservation of momentum. Instead of except that continuity of mass doesn't have any direction because it's not vector. Momentum is a vector, right? So you need to define which side you are going to apply it, x direction or y direction. But before that, let's ignore the term of round over rho t and let's write in just in x direction. Okay, so for x direction you will find out that which one is in the x direction first. These two are the velocity in x direction and this one is the velocity in y direction. So that's my x and y, right? And this is in the positive x and that's in negative x direction. So in x direction, if you ignore the terms of the time derivative term, then sigma fx, it has to be equal to control surface term v times rho v dot n times dA, right? That's your the term that instead of the, if you ignore the time derivative term because it's steady, you will have the only terms left is going to be this, right? Okay, so in x direction, what would be sigma of fx? Sigma of x is not moving in this direction, right? So it has to be 0. If that's 0, then what will we have? We have the second term should be also 0. Okay? So till here we'll write it down. But since always v dot n is just equal to magnitude of A, then what will be after that? You have velocity here that you have to write it down for each of those. Then also you have rho AV here, right, which is your m dot. So this is going to be your m dot and this is going to be your v, correct? But this v also has sometimes direction, but this is going to be your amount. Okay, so if I write it down part by part, for part 2, for this section, part 2, right? If that's your 2 part, side 2, v dot n has a amount of v, but v dot n or the sign of that is cosine of 0 and it's positive, right? And also for part 3, the same. V dot n is always amount of v, but the sign is also positive. But what about this v? It depends. For this one is positive v2 and v3, and here you have negative v2, right? Because the velocity is in the negative direction. So if I write it in this way, then I can say that m dot 3, because this is going to be your m dot, and v is negative now, right? For point 3 is positive, but for point 2 is negative. And the summation should be 0, right? This is going to be your second equation, and if you write it down by rewrite by rho pi d2 squared over 4 times v3, also you have another v3 here, minus rho pi d, this is going to be 3, and pi 2 squared over 4, and v2 is equal to 0, right? So again you can cancel out rho from each side, pi over 4 from each side, and finally we'll have d3 v3 squared is equal to d2 squared v2 squared, and that's your equation 2. Okay, So we'll keep it for now and move to find V3. Why? Let's rewrite the equation 2 and 3. So we have V1 d1 squared is equal to V2 d2 squared. That's equation 1 that we found, plus V3 d3 squared. And from this equation you will have d3, this is also needs a square power here, power of 2. Then you can also get a, because v and d always positive, you can get a square here from each side. Then you can write it only the terms without power, right? This is going to be d2 v2. Okay, so let's see what we have here. d1 is given, d2 and d3 are given, v1 is not given, but v2 is given, and v3 also unknown, right? So in this equation you have d3, you have d2, and you have v2, but v3 is not given. So we can find out from here that v3 is equal to v2 times d2 over 3. Okay, then v3 is equal to, v2 is 4 meter per second. Okay, so it's 4 meter per second, and d2 is 5 centimeter, which is if you can just keep that as centimeter, because it's going to be over 7 centimeter, which is your d3, and these two units going to be cancelled out. Then v3 is going to be 2.86 meter per second. Okay, you found v3, and in this equation these are all given. Okay, these are given, and also v1 is unknown, v2 you have it from the question by itself, it's 4 meter per second, and also v3 you find it here. Then you can find v1 also here. How? v1 is equal to, oh, you can replace that all terms in equation 1. So v1 times d1, which is 5 centimeters squared, it has to be equal to v2, which is 4 meter per second, right, times d2, which is 5 centimeter again square, plus v3, which is found here, and it has amount of 2.86 meter per second, multiplied by the d3 square, which is 0.07 meter squared. Okay, then while finding v1 is using calculator, just easily can find it. If you find it and use the calculator, then v1 is 9.61 meter per second. Okay, so applying the conservation of mass give you one equation, and applying the conservation of momentum in x direction, because it's stationary and you know the sigma of x equal to 0, then you have two equations here. And how many unknowns you have? Because if you want to find out the force here, right, in y that is asked by the question, you have two unknowns. One, you don't know what is velocity at v1, and second, you don't know what is the velocity at v3, right? You have two unknowns and you need two equations. That's why we found out by these two equations. So you have it. Now what's the next? Next, you have to make sigma Fy equal to 0, and you need force by the diagram, right? So what is force by diagram? If that's the tank, you have one weight, which is W of the tank, okay? You have fluid inside of that, which is W of water, weight of the water, and weight of the tank. These two are downward, and that's your Y and that's your X, correct? What else you have? You have another thing here, which is your scale, and this is going to be your Fy. Okay, this is the force. I can write it because of the, don't miss with the Fy. You can write it as Ry. That's the reaction force. Okay, so you are going to find Ry, but to find it out, you need conservation of momentum in Y direction. Okay, because you also have control volume and you have a momentum there. Okay, so let's write the sigma of Y equal to 0. Then Ry, which is positive, minus W of the tank minus W of the water. The water is equal to conservation of the momentum in Y direction gives you control surface V rho V dot N times dA. Okay, so if you see again, check it out, the control volume. What we have here in Y direction, the only velocity that we have in this direction is V1, right? That it only comes in. So, and V dot N is has a negative sign, right? Because V is downward and N is always normal to the surface and outward, so it's going to be upward here. Then V dot N has a negative sign. So using these three amount that you have here, then you can write it down like this. What is V? V is downward because the flow comes in. That's where V1, right? V by itself has a negative sign. Okay? Because it's V1 times negative 1 because of the direction. Also, you have a rho. V dot N by itself has a negative sign. Correct? And also A1, which is the area. And if you multiply these negative by each other, then you can write that rho A V1 squared without any sign, because the sign now is positive. So we have all of it, right? We have rho, we have A, and we have V1. We have W of water, Y, because we have the volume of the tank. It is given, it's 50 liters, and also we have the weight of the tank. So everything is known except the Ry, and you can find it out, right? So just rewrite the equation and keep Ry in one side, and instead of W of water you can write gamma of the water times volume of the tank plus W of the tank, which is given, plus rho AV squared, right? Instead of rho AV, I can use m dot, or I can just find it out by rho. So I can write m dot times V1. Keep one of V1 in rho AV, and let's have A1 here, and m dot V1, m dot 1 V1 is going to be the thing that you need here, okay? But what is m dot 1? Is rho A1 V1, right? So rho is, what's that rho? You can assume it's thousands kilogram per meter cube, times A1 is pi d1 squared over 4, and d1 is 5 centimeter, or 0.05 meter squared, okay, and V1 is you find it out from part before here that V1 is 9.61, right, times 9.61, and m dot 1 is going to be 18.9 kilogram per second. That's your m dot 1. And if you replace it here, Ry is going to be, gamma of water is kilonewton or newton per meter cube, because it's 1000 term, and over meter cube, times V of the tank is 50 liter, and 50 liter going to be 0.05 meter cube, plus W of the tank is 450 newton is given, plus 18.9 for m dot 1 kilogram per second, times V1, which is 9.61 meter per second. Using all these, then Ry is 1121, and almost that newton, and also is positive, so it means it's upward. That's the way you can calculate the force in y direction. So again, let's review the question and see how we did that. The question asks you to find this force, Ry, right? It asks you to find this Ry to find it out. You know how you have to apply the controlled conservation of momentum in y direction and using sigma fy equal to that, right? So you know what is Ry, you know the W here, W of tank, W of water, and also you need velocity of 1, right? Because the velocity of 1 gives you a momentum that is coming down, and you need to apply it because that's conservation of momentum, right? So, but you don't know what is V1, this is not given. Okay, so you need conservation of mass. To do conservation of mass, you have to make the output are equal to input. But again, you will find out that, okay, V2 is given, but V3 is also not given. So it guided you to find to apply conservation of momentum in x direction as well. So by using the conservation of momentum in x direction, you have one equation, and using conservation of mass, you have another equation. Using these two, you can find V1, and then when you find it out, you can apply conservation of momentum in y direction and find Ry. That's the whole story. So I just summarize it again to make sure you follow me till end, because it was a long question. Please do that by itself one time and make sure you understand it, because you will have something like that in the exam. And I hope you know how to don't miss that, why I need what exactly I need in this type of question. You only have two options: conservation of mass and conservation of momentum. Conservation of momentum also has two directions, so totally you will have three equations, and it will help you to find the necessary equations for make it a system of equations, find the unknowns. So in this part, there is another question, which is a jet of the air that comes in x direction, and it's not, it depends to what x and y you can consider, but just let's say that it's coming in this way and hit to the a plate, which has an angle of theta, which is 30 degree, and it's split it in two parts, V2 and V3. Okay, V2 and V3 are not given, only Vj, which is V of the jet, is given. Also D of the jet. Again, you don't know what is the depth of the plate, what is the depth, because that's a plate, so it has to be like this, right? You don't know what is the depth, you don't know what is the thickness of the jet from each of the output. So all of these are not given, but for now you know V3, V2 are not given, and also Fa is asked by part A. Okay, so let's list assumptions again. List your assumptions. Part 1. What is the assumptions? First, it is mentioned that it's circular, right? So it's a circular jet, and it's horizontal, right? What else? Can we assume that the flow is incompressible? It's also given, incompressible and invisible, right? So you have two more things here, incompressible flow, and 3 is inviscid flow. What else? In 4, it mentioned that in part A, this is stationary, right? So sigma f on the plate is 0, or a stationary plate. Okay, so these are all assumptions. Second, define your control volume, right? So control volume, make sure that your control volume is always normal to the input and output. So here is one normal, here is another normal, then also I need to make it normal here. Then for the rest of that, make sure that nothing going to pass over. So this is going to be my control volume, and make sure that N here is parallel to V2, and here is parallel to this side, and N is parallel. Okay, that's my control volume. Rho of the air is also given as 1.23 kilogram per meter cube. Second is done, control volume. Third is XY coordinate system. Define your coordinate system, because all analysis is based on that, right? So the for that, since you are going to find Fy, that's better to use Y direction and X direction, that X is parallel to the plate and Y is normal to the plate. Why? Because two of these velocities are going to be in X direction and are not going to show when you are writing the conservation of momentum in Y direction, because these are in X direction and doesn't have any component in Y. But if you consider that Y is X and Y, X is horizontal, general horizontal, and Y is normal to that, then all of these components, this is going to be only shows in the X, but two components of V2 and V3 are going to show in X and Y. Then it's going to mix it up by all the equations. You cannot find one V2 or V3 one side. It could be possible to solve it, but that's much easier to define your X and Y coordinate system like this. Okay, so what's the job? You are going to find Fa. Okay, so part A, find Fa if the sigma Fa is equal to 0, right? So Fa now is in upward, in Y direction, so it's positive. So what else? If you are going to find it out, you need conservation of momentum. So conservation of momentum in Y direction, right? So if you write it down, sigma Fy has to be equal to 0, right? Sigma Fy is equal to 0 because it's stationary. And also, what are the sigma of y? Fa, it has to be equal to the momentum. Come to surface v rho v dot n dA. Okay, so let's write it again. What we have here, we have v of the jet that has two components, one parallel to the plate and the other one is normal to the plate, right? The angle here is 30 and this is going to be 60, and v jet in y, v jet in x. Okay, so you can write it as vy and vx to make it easier. Okay, but that's again totally okay if you write it down by vj, y and x. So you find it out that you have two directions. Vjet could be has two components, one in x direction and one in y direction. For this one you need to use only the y direction ones, right? So again, rho v dot n dA is going to be your m dot that comes in, and v is the component of velocity of jet in y direction, right? So first you need to find it out that this is going to be your vy, and since vy is downward, then it has to be negative sign, okay? Because the vy, the component you have, is in negative side of y. Y is positive when it's going to in this way, and vy or vj of y is in this way. What about m dot in? M dot in is rho v dot n dA, right? V dot n is also has a negative sign because v dot n is vj times cosine of the angle between these two, which is negative 1. So you have minus, you can replace rho here. Instead of v dot n, you can write minus vj, and dA going to be your aj. Alright, so if you use these two and summarize it, so here I replace the v with vy, which is vj times which is going to be vj times cosine of the 60, and rho, replace rho here. V dot n is going to be minus vj, and dA going to be aj. Okay, so if I write it again, fy or f in a is equal to rho and aj, and instead of vj for vy I can replace by vj cosine of theta, and also negative signs going to cancel out each other. Then aj vj squared, one from here and one from here, and cosine of theta. I'll write it down again here that vjy is vy is vj cosine of theta, right? And cosine of 60 because theta is 30 now. Cosine of 60. And here also you have to write down is 60. Perfect. So what we should do, just replace the numbers and find fa, right? Fa is equal to rho, which is 1.23 kilogram per meter cube. Velocity in is 40 meter per second to the power of 2. Vj, aj is dj is 30 millimeter, and 30 millimeter pi dj, which is 30, and it's going to be 0.003, right? 3 over 1000, so it's going to be 3 centimeter, so it's 0.3 to the power of 2 over 4. And what else? And cosine of 60 is going to be half. So if you multiply all these 3, this is going to meter to the power of 2 is area, and multiply by meter is going to be meter cube. Meter cube with meter cube going to cancel out each other, and is no, that's going to give you the Newton one. So if you check the units, you will find it out that the answer would be the unit would be Newton, and FA, if you just use the calculator, FA would be 0.7 Newton. Just use the calculator again and find it out. So what we found FA when the plate is stationary, right? Okay. So what else? I'll find it out why I made a mistake. So meter per second here is to the power of 2, right? So it's meter to the power of 2 over second to the power of 2, and also you have meter square here. So you have finally meter to the power of 4 and second to the power of 2. Second power of 2 is going, one of those going to be here, and meter, you will have 1 meter here, and final unit is kilogram meter per second square, and kilogram meter per second square is going to be Newton. That's why I made a mistake. Sorry guys, but yeah, the unit should be it's the homogeneity of the units or dimension, and it has to be Newton, and it is. So we found it out that FA is 0.7 Newton when the plate is stationary. But let's read the part B. Determine the magnitude of the answering force FA necessary to allow the plate to move to the right at a constant speed of 10 meters per second. So that's changed. It means that it's not stationary anymore. It doesn't have any acceleration, but it has a constant velocity of 10 meters per second in one direction. So in the right, to the right. So what we should do? Let's write it down that is part B, and FA that is required that the plate moves horizontally. That's better to not write horizontally because horizontal direction are different. Let's write that moves with v of 10 meters per second to the right. Okay, so that's the question. If it moves to the right, what does it mean? It has a velocity, right? What does it mean that it moves to the right? It means that your control volume should be moved, right? Because the jet is here, it's going to move in this way, and also the control volume to have a velocity. So this 10 meters per second is actually a velocity of control volume, right? So velocity of control volume now is 10 meters per second in the right direction. Okay, so that's the right direction. And now you know that you have to apply the conservation of momentum again in y direction, but this is the difference, that the control volume is moving by itself. Okay, so sigma of f on control volume, as we talk about in the class, is equal to w rho w dot n dA. What is the w? W is the relative velocity, right? Is relative velocity. The only thing that you have to change instead of the previous equation to find what is the relative velocity now. So if you bring it up and if you rewrite FA here, you find it out when the plate was stationary. The FA term was positive rho Vj squared Aj cosine of theta, right? And you know that the velocity comes in from here, from to the right, with Vj as a flow like this and going up, and now you have a control volume that moves to the right with 10 meter per second. So it means that W now is V of the control V. Whenever you have a V, doesn't matter where you have, so this V also should be a component, all should be founded, but V minus V of the control volume. Okay, so here the only V that you have is Vj, and Vj is to the power of right, is to the power of 2 and also to the right. So the W now will be Vj minus V control volume, and it has to be to the right. Okay, so you can replace it here, that now if what is Fa if your plate also moves to the right. So Fa would be rho, the same equation that you have here, but instead of Vj you have to write 30 meter per second, because it's going to be 40 meter per second of Vj minus 10 meter per second of your V control volume to the power of 4 to the power of 2 times Aj, and it is 7.1 times 10 to the power of minus 4 meters squared, and also you have a cosine of theta, which is half, and rho was 1.23. The only thing that you need to change is replace the velocities with the relative velocities. So if you had Fa, that the Fa that you required for keeping the plate constant speed, or stationary, is going to be different with the force that is required to let the plate and all the control volume moves with a constant velocity. And also it would be different if you have a force that the plate also has an acceleration. That would be totally different. But if you assume that the control volume is moving with a constant velocity, then the only thing that you need to change is using the relative velocity, and we did it here. We found it out that, okay, from part A we have Fa is equal to that, but now if Vj is not the input anymore, because control volume is also moving in this way with 10 meter per second, that then means that the relative velocity of the input jet that hit to the plate is Vj minus V control volume, because the thing that plate sends for the jet is 30 meter per second, not 40 meter per second, because it has one velocity in this way. And also if you have a force that now the control volume moves in the other direction, then means that you can assume that the plate is stationary, but jet comes in and hit the plate by Vj plus V control volume, or 50 meter per second. So these are the different things that could be asked, but changing, the only you need to change the Vj or the inputs in the direction with the relative velocity. The answer for that also is 0.39 Newton. Okay, what is part 3? Part 3 asks you when the plate is stationary. So it assumes that part B, the flow, the control volume moves, but now it came back to the normal. So when the plate is stationary, that means the percentage of the mass flow rate along the plate surface for each of the flow direction. Okay, so it asks you that what is the m dot passing over here and here. So by visually it seems that these two are similar, and V2 are equal to V3, and the thickness of that is equal. But you cannot assume that, because it's not. So if you find that, write the conservation of mass, that normally everyone should do that. You have m dot in which is equal to m dot out in these two. Okay, but also it asks you that what is the percentage of m dot out from 2 and 3. So it means that these are not half by half. If that's, then you don't need to solve it. You can say that, okay, it's m dot in over 2 here and over 2 here. But it's not like that. It would be if the plate doesn't have any angle and the jet comes from upside. Yes, that would be splitting in two sides that are totally similar. But here, you cannot assume that. And okay, what are the unknowns? V2 and V3 are unknowns. You don't know what is these two, and also you don't know what is the thickness, and also you don't know what is the depth. So you don't have any area here and here. So because rho is given, and you know what is the rho, but you don't know what is V2 and V3, right? So you cannot find m dot here and here and compare with that and get the percentage of it. So only conservation of mass doesn't work. Okay, but how we can make it little change in this equation? By applying Bernoulli, since the flow is implicit and you don't have any deduction in the energy from here to here, then you can assume that you have a streamline that comes from here and pass here and comes from here and comes there. Okay, if you assume that you have a streamline and apply Bernoulli's, then you will find that out that the pressure here and here are the same. You can assume that the z doesn't change that much between these three. So z doesn't change, pressure doesn't change, and velocity should be equal. The only term that you have is left is v1 squared. So v1 squared should be v2 squared, means that vj squared should be v2 squared. Then vj is equal to v2. Also, if you apply that over here, then you can say that the same analysis applied here. Vp are equal, z are equal, and only thing that is velocity here and here, the magnitude should be equal. Only the angle change, but the velocity of 2, 3, and vj are equal. So I write it down here for you and showed you what is the streamline. So that's my input. You found it out that if it's inviscid and the flow is incompressible, and also along the streamline with the steady state condition, you can apply Bernoulli, right? So the only thing you have to assume two streamlines here. One streamline that passing here and one streamline here. Okay? So between point 1 and 2 or point 1 and 3, you can apply Bernoulli. But let's say between 1 and 2. If I apply Bernoulli between 1 and 2, then I have P1 over rho plus Vj squared over 2j plus Z1. And also in point 2, I have the same terms with subscription of 2. But both of them are in atmospheric pressure. So static pressure is the same. I can say that P1 and P2 are the same. Also equal to P3, right? Also, you don't have that much the huge size of the plate, so you can assume that the Z1, 2, and 3 are almost the change of z is negligible, right? Then you have to cancel out these terms, P2 over rho, because rho is constant now. This is going to cancel out with this one, and this is going to be cancelled out by Z2. Then finally 2g or 2 times g also going to cancel out. Then what will you have finally? Vj equal to v2. Both of them are into the power of 2. But since we can get the squarity from each side, then Vj equal to v2. The same analysis for v3 gives you that v1 or Vj equal to v2 equal to v3. Right? So here, again come back here. What it asks you to do, it asks you to find the mass flow rate difference percentage that pass over V2 and V3. But now you deducted, you found that if you write down the conservation of mass, that's not enough, because you have one equation and you don't know what is the areas here and here, right? You don't have the the thickness, and you don't know what is the velocities here. But now with the streamlines and the Bernoulli's equation, you find it out that Vj is V2 and V3. So V2 and V3 should be 40 meters per second. Okay. Now you can apply conservation of mass, and since you deducted the number of, you bring it down the number of unknowns, because you ignore V2 and V3 are different, and based on the assumptions you find it out that V2 and V3 are equal to Vj, then you can apply conservation of mass, and it's enough for you to find it out the percentage. How? Let's apply it. So what we have here in part C, we know that V2 are equal to V3 is equal to Vj, right? Okay. What else? We can say that conservation of mass gives us that m dot j, which is input, should be equal to m dot 1 or 2 plus m dot 3, right? That's the conservation of mass. It means that the amount of the mass flow rate that comes in should be equal to the out, because that's a steady state, you don't have any other term. Okay, so you find it out that these two are the summation of these two are m dot j, but again you cannot say that how much of this m dot j is inside of m dot 2 and how much of that is inside of m dot 3. Why? Because you don't have two thickness of the output jets. So you keep that as equation 1, but let's try the x direction of momentum. Conservation of momentum in x direction. So if you write it down in x direction, then what's that? In x direction, you have any also make sure that y and x are like this. X is the plate. If that's the plate, then this is your x direction, okay? And you have V2 and V3 that are passing over there. And you have one of the jet's velocities component in x direction. If that's your Vj, then this is going to be your Vx of j, right? These three are all given. If you write it down, the conservation of mass, then sigma of x has to be 0, then control surface of V rho V dot n dA should be 0. Okay, perfect. So three terms is needed to be calculated. Why? Because you have Vj, V2 and V3 and all are in x direction. Okay, so what are those? In Vj, component of x in positive x direction. Okay, so you can write it down that Vj of the x, which is Vj cosine of 30, right? That's Vx is Vj cosine of the angle, which is 30 degrees. Okay, we can replace it. So Vj cosine 30 is the V, and also for the m dot part, it has to be V dot n, because that's input. The sign is negative, right? So you can say that is going to be times minus rho Vj aj. Okay, that's the input part. What else? For the output part, you have velocity of the 2 and velocity of the 3. Okay, so for velocity of 2 is by itself is in positive x, but velocity of 3, which is here, V2 and V3, velocity of 3 is negative, right? So by itself it has a negative sign. For 2, you can write that V2. And also for this part, since these are output, this is going to be rho A2 V2. Correct? Perfect. And what about part 3? Part 3, V3 has a negative sign, right? And also row A3, V3 is the m dot. And summation of all should be 0. What we can apply here? We can cancel out all the rows because row is a constant, and we find it out that V3, V2 and Vj are equal to V, right? They are equal to each other. And also we can write it here that or that's better to just replace these VV, and that's going to be our m dot, right? You can say that this is my m dot j, and that's my m dot 2, and that's my m dot 3. Why we are going to do that? Because we have another equation here that are between mj and 2, m dot 2 and m dot 3. So if we rewrite this equation as well in this way, then we can compare these two and solve that how much of the mj pass over m2 and how much of that is going to pass in 3. Okay, so if you replace that with mj and bring the negative sign here, this is going to be minus vj cosine of 30 times m dot of j. Okay, plus for this one you will have v2 m dot of 2, and for this third part you have negative sign of v3 m dot 3. Okay, it has to be 0. Perfect. So what we can do, we can replace one of these two with the equation that we have here. So if you, for example, we replace m dot 3, which is m dot j minus m dot 2, right, from equation 1, then we can say that this is going to be minus m dot j times minus v, and also let's assume that vj and v2 and v3 are v. So v cosine of 30, right, v m dot 2 plus or minus v times m dot j times v, and plus v m dot 2, and all of these should be 0. Correct? So I can rewrite it again here. Then by replacing these two, we have m dot j minus v cosine 30, right, plus m dot 2v plus m dot 2v again, this one, and minus m dot j v equal to 0. Okay, so bring these, the negative terms, the other side, then you will have m dot 2 m dot 2 v, it has to be equal to m dot j v cosine of 30 plus m dot j v, right? And now you can cancel out the v's from each side, then m dot 2 is equal to m dot j times 1 plus cosine of 30 over 2. And this is going to be, by using calculator, it's going to be 0.933. Okay, then you can say that m dot 2 is 0.933 m dot j What about m dot 3? M dot 3 is 1 minus m dot 2. 1 minus 0.933 times m dot j, which is 0.067 m dot j. Means that how much of these two, how much of them dot j pass over part 2 and how much of that pass over part 3. So I have another question that I wrote the explanation for that, but that's much easier than these two questions, and I will post it in the webinar, and you can follow the solution of that. If you have any other question, I'll be available in the office hours. I will help you with that. I hope that these are helping you. These will help you for the homework 5 submission, and have a good day.